base can then move from the center of the truss where we need it on EVA-1, near the Z1 truss, out to the far port end of the space station for EVAs 2 and 3 for those battery R&Rs. On flight day 3, we'll finish up by isolating Garrett and Steve in the airlock as they prepare for EVA-1 the next day. Moving on to flight day 4, it's our first EVA day. Lisa Shore will be giving you a detailed EVA briefing immediately after, or shortly after this briefing, so I won't cover those in detail. We'll just cover them at a very high level. For EVA-1, our EV crew members are Garrett Reisman and Steve Bowen. Garrett will be EV-1 and Steve will be EV-2. Ken, Mike, and TJ will be helping them get suited up in the airlock. Tony, as Mike mentioned, will be our IV crew member helping them through their timelines through the EVAs. Piers and Tracy will be providing SSRMS support, and the SSRMS and EVA operations for each of the 3 EVAs are highly integrated, and we're highly dependent on that integrated timeline going well. The big picture items for this EVA are going to be the installation of the redundant space-to-ground antenna system and the EOTP. Then we will send Steve over to the ICC VLD where he will release the launch torques that were put on the ICC VLD batteries, which will save us some time in EVAs 2 and 3. We estimate the EVA is going to take about 6 hours and 30 minutes. And then at the very end of the day, as the EV crew members are coming back inside, Ken and Tony will be positioning the shuttle arm immediately over the MRM-1 so that we can pull it out of the bay the next morning. The highlight of Flight Day 5 then will be the MRM-1 installation, and we have animation of that one as well. Not shown in the video, Ken and Tony will grapple MRM-1, then Piers is going to deactivate the module in the payload bay. It'll be pulled from the payload bay to a position where the station arm can reach it, and then Garrett and Piers will grapple and reactivate the module on ISS power. The shuttle arm will then ungrapple, move to a viewing position while MRM-1 begins its trip across the space station over to the nadir port of the Zarya module. Again, I expect these views to be pretty spectacular. Piers, once MRM-1 docking system is aligned with the Zarya docking cone, which you'll see here shortly in the video, Piers will initiate an automated docking sequence that will complete all the mechanical, electrical, and data connections within the interface automatically. Again, this video is actually much faster than what we'll see in real life. Once MRM-1 installation is complete, we'll use the station arm to pull OBSS off the side of the shuttle payload bay, hand it off to the shuttle arm. Then, if there are any concerns about the integrity of the shuttle's thermal protection system, we'll inspect any trouble spots. And if there are no issues, then the OBSS will be positioned for viewing of EVAs 2 and 3. We'll finish up Flight Day 5 with a review of the EVA-2 procedures, and then we'll get Steve and Mike in the airlock to get ready for EVA-2. Overnight, the ground teams are going to translate the mobile transporter with the ICC VLD on top of it over to the port side of the vehicle in preparation for the EVA work the next day. On Flight Day 6, we'll start the morning off with Garrett and Piers taking the ICC VLD off of that mobile base system and getting it positioned for the EVA crew members to have access to it. Meanwhile, Steve Bowen, who will be our EV-1 for EVA-2, and Mike Good, our EV-2 for EVA-2, will be getting ready in the airlock. This time, Tracy and Ken will be helping them get suited up. Tony will again be our IVA walking them through the procedures, and Garrett and Piers will provide the SSRMS support throughout the EVA. The big picture for this EVA, we're going to do 3 battery R&Rs. The goal at the end of the day, after about 6 hours and 30 minutes, is to have taken 3 batteries from the pallet, put them on the truss, taken 3 batteries from the truss, and put them back on the pallet. Then we move into Flight Day 7, where we get some crew off-duty time at last. We'll be getting tools configured for our EVA-3, and our Russian colleagues will be doing the very first steps to get MRM-1 opened up and begin filtering the air in that module. We won't do a significant ingress of that module until after the docked mission is complete, because it's so full of cargo you just can't get very far into it without having some space for that cargo, and we just don't have that space when we've got 6 visitors on board station. At the end of the day, we'll be doing an EVA-3 procedure review, and then we'll get Mike and Garrett into the airlock for camp out in preparation for Flight Day 8, EVA-3. This time, Michael Good will be our EV-1, Garrett Reisman will be EV-2. Again, Tony is IV, with Steve and Ken helping them get suited up in the morning. Piers and Tracy will provide the SSRMS support. We'll resume our P6 battery R&R activities, replacing the old batteries on P6 with the new ones on the pallet. Again, swapping those 3 out so that we should have 6 old batteries on the pallet and 6 new batteries on the truss by the end of this 6-hour and 15-minute EVA. We'll do some P6 cleanup at the very end, and then if time allows, there is a grapple fixture attached to the port side of the shuttle payload bay that we would like to have on ISS. So we, as time allows, we'll send the crew down there to retrieve it, bring it inside. It'll then get some minor modifications and then be taken back outside on an ISS stage EVA for installation on the FGB. At the very end of the day, we'll have Piers and Tracy maneuver the ICC back onto the mobile base system so that overnight the ground teams can translate it back to the center of Space Station and preparation for it to be returned to the payload bay on flight day 9. And speaking of, I think we have video of that activity. Garrett and Piers this time will grapple the ICC VLD with the SSRMS, and then we'll ungrapple it on the POA there on the mobile base system, then swing it around and return it to the payload bay. And at this point, the only hardware left on that pallet should be our 6 old batteries returning home. The rest of this day is crew off duty, and we have several science experiments scheduled for execution on this day, as well as a great deal of our transfer. We don't get as much transfer done as we'd like while the guys are outside, so we're going to make up some time on flight day 9. With that, I'd like to hand it back over to Mike to brief the undocking and the remainder of Atlantis' final flight.
Thanks, Emily. Flight day 10 will wrap up the joint mission activities between Atlantis and the International Space Station crew. The crew will check out a number of the systems required for undocking and fly around, the rendezvous tools. They'll have a press briefing, a joint press briefing with the International Space Station crew, say their final goodbyes, perform the hatch closure, and some leak checks to make sure that the docking interface is ready to go for the next space shuttle arrival. And then we'll perform the undocking and fly around. We have a animation of the undocking that we'll show you. Pilot Tony Antonelli will back Atlantis away from the International Space Station at a range of 400 to 600 feet, and then complete a 1 revolution fly around, again, to obtain imagery of the exterior of the International Space Station. We'll take digital still images. Those will be downloaded to the ground for review and analysis before performing a final separation burn. The lap around the International Space Station will take about 45 minutes and will be conducted during the daylight portion of the orbit. Following the fly around, that'll wrap up flight day 10 for the crew of Atlantis. On flight day 11, they'll start the process of returning home. As part of that, they'll perform the late inspection and give a review of the heat shield of Atlantis one more time. We have an animation of the late inspection process. This inspection is a little bit different than what we saw on flight day 2. We don't survey the tail end of Atlantis because we're not worried about ice from the ascent loading of the cryogenic fluids or the ascent environment effects on the thermal blankets. What we're looking for here is orbital debris or any damage on the hottest surfaces of Atlantis on the reinforced carbon-carbon along the leading edge. If we do notice any damage, the team will review that imagery and determine whether or not it exceeds the threshold that requires a repair. If we need to repair, we've got the tools and techniques in place to make that happen. The imagery team on the ground will use a very similar process to what they did earlier in the mission to review all of the inspection data from the boom after the starboard nose cap and port wings are surveyed, and will provide a very quick turnaround on all of that data that gets reviewed roughly a day after the inspection activity is complete. At the tail end of the inspection, we'll put the robotics away for the final time on this mission. So this will wrap up all of that man and machine work that was conducted throughout the mission.